I'll be going over the 2011 FRQ question number 6 from the 2011 AB Calc Form B exam. And it's just basically a series question. All we need to know is this series right here that we're going to be using for parts A, B, C, and D. So with that being said, let's start with part A. So in part A, we are given a series, the one that we saw in the equation, and that one is it's which I have right here. So this is just a series that we have, and then this is, by the way, ln of 1 plus x, and all we're supposed to do for this one is we're asked to write a series for ln 1 plus x cubed. So all you have to do is take this x cubed and plug it in wherever you see an x in the original series. And that's what I've done right here. You just use direct substitution. There's no special anything. You just plug in the x cubed wherever there was an x in the original series. And once you do that, you can just simplify. So x cubed minus 2 times 3 is 6, x to the 6 over 2, so on and so forth. And that's all you need to do for part A. Now we're going to be using what we found in part A in several other parts of the problem. Now for part B, we are told that the radius is 1, and we are asked for interval of for the interval of conversions, and therefore we need to know that the center of the series is 0, which is from the series itself. You can see that in the series itself. So with that said, we're also asked to we need to test x equals -1 and x equals 1 in the series that we have found in part A that I told you would use later. All that means is the series right here. I have it written again. So let x equals -1. Once you plug in -1 for x cubed, for x to the 6, x to the 9th, you're going to end up getting -1, minus 1/2, minus 1/3, minus 1/4, so on and so forth. So you can see minus, 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 just repeating. Pattern is can be referred to as the negative of harmonic series. And any negative harmonic series, you should just keep it in mind, have it on you all the time, diverges. And then for x, you just do the same exact thing. For 1. You just plug in 1 into the series, and you're going to get 1 minus 1/2 plus 1/3 minus 1/4, so on and so forth. And then this is, as you can see here, it's minus, plus, minus, plus, minus, plus, minus, plus, and that is, it's alternating. So it's going to be called the alternating harmonic series, and any alternating harmonic series converges by AST. AST is the alternating series test, and because we were able to say have these two statements, we can say that the interval of conversions is from -1 not included to 1 included. Okay, now moving on to part C. Well, for part C, we're asked to define a whole new function, and that whole new function is right here, and we're supposed to find f prime of t squared. So what I've done here, I've taken the derivative of the series that we have found in part A. So I have it another time right here. This is the series we have found in part A, and all this is just f prime of x is just taking the derivative of each term of the series. And then in order to find f prime t squared, all you really have to do is just plug in the t squared wherever you see the x in the f prime that we have found. Just plug in the t wherever you see an x. That's all you have to do for f prime t squared. We did all this because we are given this g of x. We're given that it's equals the integral of 0 from 0 to x f prime t squared dt, and we're asked to approximate g of 1. So g of 1 is going to equal integral of bounds being 0 and 1, because since it's 1, we can plug in 1 right here because this is a coefficient on top. So it becomes our bound. So f prime of t squared dt, this is what it should equal. It's approximately, however, integral from 0 to 1, 3t to the 4th minus 3 to the 10th, and I'm just picking the first two first two terms from the f prime t squared that we have found right here. And to solve that, it's just the reverse of power rule. So you just add 1 and multiply by the reciprocal. So doing that, you get 3 over 5 plus t to the fifth minus 3 over 11t, and then you take the bound, you just plug in the 1 for the t's, plug in the 0 for the t's, you can get 3 over 5 minus 3 over 11. That is your answer for part C. Now for part D. Part D asks, all it is asking is, it's asking for the error in the last calculation, and we need to know that alternating series error is less than the absolute value of the first term left off. It's just something that we need to know. So for the first term left off, it's gonna be from the integral from 0 to 1, 3t to the 16th, and if you go back and look, this is actually my next term, or the third term in the sequence. 3t to the 16th dt, and then just doing normal integral, you take 3 over, it's going to be 3 over 17 to t raised to the 17th power, and then you have the bounds that you need to go and plug into the problem. You go 1 and 0, subtract, you're going to get 3 over 17 as your answer, and 3 over 17 is less than 1/5, which is what we were asked to prove in part D. And that's all for this problem. Hope it helped.